Hi, in this video we are going to talk about the average atomic mass. So we know inside an atom we have nucleus, and the nucleus is made of neutrons and protons, and electrons are orbiting around the nucleus. Okay, now the mass of neutron is 1.68 multiplied by 10 power negative 24 grams. Mass of proton 1.67 multiplied by 10 power negative 24 grams. Mass of electron 9.11 multiplied by 10 power negative 28 grams. Okay, it's such a pain to calculate all these numbers to get the atomic mass of an element. So chemists, they use the letter U instead of calculating all these numbers and to get the atomic mass. So U is for the atomic mass. Some people they write AMU or Daltons. Okay, Dalton is a name of a chemist. Okay, and now chemists used carbon 12, which is an isotope of carbon, to know the atomic mass of other elements. For example, we want to know the atomic mass of hydrogen. Carbon is bigger than hydrogen, in 12 times. So if we divide 12 by 12, we get 1. We want to know the atomic mass of helium. Carbon is bigger than helium in 3 times. So if we divide 12 and 3, we get 4. So the atomic mass of helium is 4. Okay, so now let's know how to calculate the average atomic mass. So let's learn how to calculate the average mass. Let's go. So I'm going to erase everything here because I'm going to draw a chart. Okay, and the first example, it's going to be carbon. I'm going to put 2 isotopes of carbon. Okay, here one chart. Okay, I separate this, separate this. I'm going to have here 1, 2, 3, 4, 5, 6 boxes. Okay, let's start. Here we're going to put carbon 12, which is an isotope of carbon, and carbon 13. And I need to write the atomic mass, okay, and the percentage. Here we have 98.89 percentage of carbon 12 we have between carbon. We have 1.11% of carbon 13. Now carbon has a lot of isotopes. It has 25 isotopes. I chose only carbon 12 and 13 because they have more percentage than other carbon isotopes. So I just took carbon 12 and 13. Now let's start. And the first rule is to what? Let me tell you it. It's to convert the the percentage abundance, okay, the percentage abundance converted to decimal fraction. So how can we convert a percentage to decimal fraction? We divide the percentage by 100. So 98.89 divided by 100, we get, if we move the decimal point two decimal places, 1, 2, going to get 0.9889. Okay, now if we divide 1.11 by 100, if we move the decimal point 2 decimal places, we're going to get 0.0111. Let me erase this. Okay, the second rule. To explain the second rule, let me tell you an example of A and B. Let's say A is carbon 12 and B is carbon 13. So this is A, this is B. So I need to write the atomic mass of A multiplied by the decimal fraction of A plus the atomic mass of B and the decimal fraction of B. Okay, and we get, for example, the answer of AB. Okay, so did you understand what we have to do? We write the atomic mass multiplied by the decimal fraction, add the atomic mass of B, the decimal fraction of B, and get the answer of, for example, AB. Okay, now let's do it for carbon. I need here space. Okay, write the atomic mass of carbon 12. It's 12U multiplied by the decimal fraction plus the atomic mass of carbon 13. Don't forget the unit, U, multiplied by the decimal fraction of carbon 13, which is 0.0111. We get the answer of 12.0011. Okay, so this is the answer. Let's take another example. And this example is for oxygen. Let me erase everything here. Okay, so I'm going to use the oxygen 16. Okay, let me put a line here. I'm going to use oxygen 17. And the last one, it's going to be oxygen 18. Okay, now let us write the atomic mass of oxygen 16, which is 16U. Here, 17U. Here we have the last one, 18U. Okay, let's write the percentage. Oxygen 16, it has 99.76. Then here for oxygen 17, 0.04. Oxygen 18, 0.2. Okay, so do you remember, guys, the rules? Let's do them. Okay, let's continue. So the first rule, we need to convert the percentage abundance to convert it to what? The decimal fraction by dividing 100. 99 divided by 99.76 divided by 100. We're going to get, by moving the decimal point 2 decimal places, 0.9976. Okay, 0.4 divided by 100, move the decimal point 2 decimal places. This is the number. Okay, the last one, 0.2, we divide it by 100, move the decimal point 2 decimal places. Going to get this 0.002. Okay, let's continue. Second rule. So the second rule, do you remember it? Yes. What we have to do is that we're going to write A for oxygen, only to practice more. Okay, let me use another color. A for oxygen 16, we're just here practicing. B for oxygen 17, and C for oxygen 18. Okay, as we said the rule, we write the atomic mass of A, we multiply it by the decimal fraction of A plus the atomic mass of B multiplied by the decimal fraction of B, plus here we have an extra isotope, so we write C plus the atomic mass of C multiplied by the decimal fraction of C, and we get the answer of maybe for example ABC. Okay, now let's do it for oxygen. Let me erase everything here and we start. We're at the atomic mass of oxygen 16. It's 16U multiplied by its decimal fraction. It's 0.9976 plus 17U, which is the atomic mass of oxygen 17, multiplied by 0.00. Here we have 0004. Here third 4 plus the atomic mass of oxygen 18, which is 18U, multiplied by the decimal fraction, which is 0.002. And we get, so calculating 16 multiplied by this and this and this, we're going to get the answer of 16 point 44. Okay, so this is our video for today, and we learned, before I end up this video, we learned a lot. We learned how to calculate the average atomic mass, and we learned about what is U, and we learned the numbers or the way of proton, neutron, and electron. So we had fun today. So this is our video for today, and thank you for watching. See you later. I hope you enjoyed.